For this lesson, we'll explore real numbers and the number line. Let's take a look at the square root. It's defined as a number A is a square root of a number B if A squared is equal to B. Now what that means is, let's say we have 3 squared equals B, but we know B is just 9. So the number A, in this case it's 3, is known as the square root of B, in this case is 9. Now let's take a look at the radical. We have the actual symbol, which is defined here. And the radicand is the letter A. It's inside the radical symbol. And the whole thing is called the radical. Right? It's an expression made up of the radical symbol and the radicand, or the number that is inside the radical symbol. Okay? Alright, let's take a look at what a perfect square is. By definition, it says the square of an integer is called a perfect square. So let's do a quick example. Let's say we have 7, that's the integer, and we are going to square it. Okay, and that equals 49. So the integer we're looking at is the 7, and we are squaring it, hence the 2, and it's equal to the 49. So the 49 is the perfect square. Okay. A rational number is any number that you can write in the form AB, the fraction AB. Okay. A and B are integers, and B cannot be 0. Right? B can't be 0. Your denominator cannot be 0. Down below, we have subsets of what a rational number is, right? We have a couple of them. The first one is natural numbers, all right? Or we can call them counting numbers. We start off with 1, then you go to 2, 3, and so on, okay? And here's an example of what those numbers look like when they're plotted onto a number line, right? Another subset, okay, of rational numbers are whole numbers, right? The only difference between natural numbers and whole numbers is the 0, right? And then it goes up again, 1, 2, 3, and so on. And this is what it looks like on a number line, right? Another subset of rational numbers are integers, right? And you can have negative integers like -2, -1, you can have 0, then you can have the positive integers 1, 2, 3, and so on, right? And here's what the integers look like on the number line. Okay? Right, here's a nice chart of all the numbers. Right, we start off with natural numbers. Right, the first box there. You have square root of 25, you have 7, you have 4 over 2. Those are all natural numbers. Right? And then you work your way out, then you have whole numbers. Right? So we can say all natural numbers are whole numbers, but not all whole numbers are natural numbers. Right? That's how it works here. And then all whole numbers are integers, but not all integers are whole numbers. Right? Because you have negative integers here, and those can't be whole numbers. Right? And then you move your way out to a set of all rational numbers here. And it's made up of integers, whole numbers, and natural numbers. Right? Integers, whole numbers, and natural numbers. And on the other side are the irrational numbers. Okay. For example, like radical 10, negative square root of 123. Pi is a really nice one. Goes on forever. Right? There's no pattern to it, so that's what makes it irrational. Alright, to define what a rational number is, by definition here, we can say a real number that can be written as a ratio of two integers, like looked at before, a and b, where b cannot be 0, right? Rational numbers in decimal form are either terminating, so it stops. So for example, like 0.5, right, it stops right there. Or repeating, for example, you can have 0.3333 repeating. Right? These are examples of rational numbers. Irrational numbers are numbers that cannot be written as a ratio of two integers. Right? So you cannot write it in terms of a over b. Right? And the best example is pi, right? Because it's 3.14 and it keeps on going, right? It's non-terminating, so it doesn't stop, right? Pi goes on forever, indefinitely, and it's non-repeating. It doesn't repeat. The digits don't repeat, right? So here's an example of an irrational number. Radical 2 would be another example of an irrational number. Alright, let's define an inequality, and it's basically just a mathematical sentence that compares the values of two expressions using an inequality symbol, right? So here are the symbols. We have the less than, we have the greater than, and we have less than or equal to, then we have greater than or equal to, right? Those are the symbols that we use in an inequality. If we were to compare these two numbers, square root of 17 and 4 1/3, well, let's find out what the square root of 17 comes out to. So it's approximately 4.12310, and 4 1/3 comes out to 4.3 repeating. Now we know that 4.12310 is less than 4.3 repeating, so we can say 4. Actually, let me make it the same color. 4.12310, right, which is just radical 17, is less than 4.3 repeating, right? So less than 4 1/3, right? And that's how you would compare the two numbers. So here's a question, and we have to put these numbers, radical 4.4, negative 2 over 3, radical 2, and negative 1.5, from least or smallest to greatest or biggest, right? You can pause the video right now, and then I will give you the answer in maybe 10 seconds. Okay, if you picked C as your answer, then you are correct. Right? Give yourself a nice smiley face here. Right? And that's it for this unit.